Let's take a look at another functional equation. It says let f from natural number to natural number be strictly increasing function that satisfy f of n equals 3 times n for every natural number n. Determine f of 2006. So this problem is probably from a mathematical competition in 2006. So this is an interesting question. Let's see how to solve this one. So strictly increasing is a very important condition. We will make use of this one because the domain and the range is for natural numbers, which means that we need to count the number 1, 2, 3 like that. So maybe like we will have f of n plus 1 should be larger than f of n for every natural number n. And also, for the original functional equation, we have a composite function of the left-hand side. So we have double composite function on the left-hand side, so you should always try to have the third composite function. So for the original equation, let's take f on both sides so that we will have f of n equals f of 3n. And from the original equation, if we replace n by f of n, we will also have f of n on the left-hand side. However, on the right-hand side, it would become 3 times f of n. So in this case, we successfully simplify the original equation like this, and we may call it equation 1. So from the original equation, we may try some initial value so that we can come up with some idea how to find the general solution for different number. So let's try. From the original equation, let's substitute n equals 1. So we will have f of 1 equals 3 times 1, which is 3. And then n equals 2, we will have f of 2 equals 3 times 2, which is 6. And then f of 3 should be 3 times 3, which is 9. So maybe it's quite enough for the moment. So next, in equation 1, we also repeat this procedure. So we will have f of 3 equals 3 times f of 1. And then for next, we have n equals 2. So we have f of 6 equals 3 times f of 2. Then n equals 3. We will have f of 9 should be 3 times f of 3. So we come up with 6 identity. So now let's try to guess what should be f of 1 and so on. So now we have f of 1. Let me guess. If f of 1 equals 1, then f of 1 should be f of 1, because f of 1 is 1, and this is 1. However, here we have f of 1 should be 3. So this one is conflict with what we derived here. So f of 1 cannot be 1. And if f of 1 is larger or equal to 3, then f of 1 should be larger or equal to f of 3. F of 3. Because f is strictly increasing. And according to this one, we have f of 3 equals 3 times f of 1. So this is 3 times f of 1. And f of 1 is larger or equal to 3. So it should be larger or equal to 3 times 3, which is 9. However, f of 1 should be 3 here. So this also conflicts. with what we derive. So the only possible value for f of 1 should be 2. So we have f of 1 here, and we can make use of equation 1, so that we can have f of 3 should be f of 3 times f of 1, which is 3 times 2 equals 6. And we can have f of 9, which is 3 times 3. So it should be 3 times f of 3, which should be, maybe we can write it as 2 times 3 squared. And this one is f of 3 squared. So we can come up with some idea to know that if n is 3 to the kth power, f of n should be 2 times 3 to the kth power. For k should be from 0, 1, 2, etc., etc. So actually, we can prove this one by mathematical induction. So for the initial condition, is already satisfied. For n equals, for k equals 0, this is good. This is already checked, because when k equals 0, which means f of 1 is 2. So this is okay. So if k equals p, for k equals p, which means we assume f of 3 to the p power equals 2 times 3 to the pth power. Then for k equals p plus 1, which means that f of 3 to the p plus 1 power, using equation 1, we should have 3 times f of 3 to the pth power. And this one, we should have 3 times 2 times 3 to the pth power, which is 2 times 3 to the p plus 1 power. So actually, we proved this one. So in this case, we can have f of 3 should be 3 times 2, which is 6. F of 9 should be 3 times 6, which is 18. So now we already come up with f of 1, f of 3. Why not we can try to find f of 2. So now f of 1 is 2. F of 3 is 6. So there are only 3 possible, and actually f is strictly increasing, which means that f of 1 is smaller than f of 2 is smaller than f of 3, which means that f of 2 equals 3 or 4 or 5. So now if f of 2 is larger or equal to 4, which means that f of 2 should be larger or equal to f of 4, because f is strictly increasing. In this case, f of 4 should be larger than f of 3. Still, f is strictly increasing. So f of 3 is 6. However, here we have f of 2 equals 6. However, and in here we have f of 2 is strictly larger than 6 because this is strictly larger. So this is conflict with this one. In this case, f of 2 can only be 3. So we have f of 2 equals 3. So still using equation 1, we can have f of 2 equals 3. So we have f of 6 would be 3 times f of 2, which is 3 squared. And also we can use mathematical induction to prove that f of 2 times 3 to the k power should be 3 to the k plus 1 power. Actually, I do not repeat the mathematical induction here. You can simply follow this procedure to prove this one. So now we know that f of 6 f of 6 should be 3 times 3, which is 9. So now we know f of 3 and f of 6. So we can try to guess what should be f of 4 and f of 5. So now we have f of 3 is 6. F of 6 is 9. And f is strictly increasing. And the only integer between 6 and 9 is 7 and 8. 7 and 8. Which means that f of 4 can only be 7. F of 5 can only be 8. So that f is strictly increasing from 3, 4, 5, 6. Because this is 6, 7, 8, 9. The only possible way to make f to be strictly increasing. So we can try to come up with if n is smaller than, so now we have a f of 4 to be 7, f of 5 to be 8. So now we should have if n is larger than 3 to the k power and is smaller than 2 times 3 to the k power. We already come up with f of 3 to the k power should be 2 times 3 to the k power, and f of 2 times 3 to the k power should be 3 to the k plus 1 power. So now we can see here, we can subtract these two numbers so that we have 2 times 3 to the k power minus 3 to the k power, which is, we can factor out 3 to the k power so that we have 3 to the k power multiplied by 2 minus 1, which is 3 to the k power. Also, we can subtract these two numbers so that we will have 3 to the k plus 1 power minus 2 times 3 to the k power, which means it should be like 3 to the k power multiplied by 3 minus 2. And this is actually 3 to the k power, which means that these two difference is 3 to the k power. This two number is also 3 to the k power, which means if n is larger than 3 to the k power and smaller than 2 times 3 to the k power, and n can be written as 3 to the k power plus r, where r should be smaller than 3 to the k power and is larger than 0. Then f of n should be f of 3 to the k power plus r. So that is the only possible way that f is strictly increasing. And this is 2 times 3 to the k power plus r. So it is like 3 to the k power plus r plus 3 to the k power. And here we have 3 to the k power is 3 to the k power plus r is n. So it is n plus 3 to the k power. So now we come up with another expression like if 3 to the k power is smaller than n is smaller than 2 times 3 to the k power, then f of n equals n plus 3 to the k power. So now we should also try to consider what is f of 7, f of 8. We can simply observe that f of 6, f of 9, there are only two numbers in between, but f of 6 is 9, f of 9 is 18, so it cannot be a consecutive integers. 9, 8, 9, 10, 11 is not the case. So possibly it should be like f of 7 to be 12, f of 8 to be 15. Why? We can see that f of 4 is 7. So f of 4 is f of 7. If we take it on both sides, take f of both sides. And according to the original equation, if we pick n equals 4, then f of 4 should be 3 times 4 equals 12. So this is that case. And if f of 5 is this one, should be f of 8. So this one should be 3 times 5 using the original equation and substituting n equals 5. So it should be 15. So this is that case. So now, if n is larger than 2 times 3 to the k power and is smaller than 3 to the k plus 1 power, what should it be? It is like, n is equal to m plus 3 to the k power. And in this case, we substitute 3 to the k power on the whole equation. We will have 2 times 3 to the k power minus 3 to the k power is smaller than n minus 3 to the k power is smaller than 2 times 3 to the k power. It should be 3 to the k plus 1 power minus 3 to the k power. So this one will be 3 to the k power is smaller than, using this one, we will have a m here, and it is smaller than 3 to the k plus 1 power minus 3 to the k power. It should be 2 times 3 to the k power. So in this case, it is in this region. So f of m is m plus 3 to the k power. So let me pick f on both sides. So we have f of f of m equals, and actually this one, m equals, m plus 3 to the k power is actually n. So this is f of n. And using the original equation, f of m should be 3 times m. And m is 3 times n minus 3 to the kth power. So we come up with f of n equals 3 times n minus 3 to the kth power. So, concluding the four highlighted equation, we have f of 3 to the kth power should be 2 times 3 to the kth power. And then we have f of 2 times 3 to the kth power should be 3 to the k plus 1 power. Also, if n is, let me see, we have f of n should be n plus 3 to the k, f of n should be n plus 3 to the kth power if n is larger than 3 to the kth power and is smaller than 2 times 3 to the kth power. And f of n should be 3 times n minus 3 to the kth power if n is larger than 2 times 3 to the kth power and is smaller than 3 to the k plus 1 power. Actually, all these four conditions also cover all the natural number. So this looks like very complicated, and actually you can express it in another way. Usually you will familiar with the binary notation, which is like if we have 0, which is 0, which if we have 1, it is 1. If we have 2, it is 1, 0. If we have 3, it is 1, 1. If we have 4, it is 1, 0, 0. Of course, for the binary notation. So on and so forth. And actually, we can use the base 3 notation, or we can call it the trinary notation, which means that if we have 0, it is 0. If we have 1, it is 1. If we have 2, it is 2. If we have 3, it is 1, 0. If we have 4, it is 1, 1. And if we have 5, we have 1, 2. If we have 6, we have 2, 0. So on and so forth. With base 3 or trinary. Which means that we can rewrite it using the trinary notation. So if n is, let me see, k minus 1 up to a0 in trinary notation, if ak equals 1, then f of n is 2 ak plus 1, ak minus 1 up to a0 in trinary notation. If ak equals 2, then f of n equals 1 ak minus 1 ... up to a0, and then we have an additional 0 at the end. Or you can regard it as you change the first digit to 1, from 2 to 1, and then we add a 0 at the end. So this is actually like this. So we already come up with the general solution for this functional equation. And of course, we can find f of 2006, of course. So f of 2006, let me find out what is the range of 2006. So we have 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27, 3 to the fourth power is 81, 3 to the fifth power is 243, 3 to the sixth power is, let me see, 729, 3 to the seventh power is 2187. Okay, so now this number is already larger than 2006. So, and of course, 2 times 3 to the sixth power is 1458. So we can see that 2006 is smaller than 2000, or maybe we can write it as is smaller than 3 to the 7th power and is larger than 2 times 3 to the 6th power. So we can express it as 2006 equals 2 times 3 to the 6th power plus which is like 2006 minus 1458. So this number should be 8. This is 4. This is 5. So 548. So in this case, we have the first digit to be 2, which means that it should change to this case. Or we can actually use this expression to find f of 2006. So f of 2006 is like 3 times 2006 minus 3 to the kth power, 3 to the 6th power, which is 729. So for this one, it will be like 3 times 7, and then here we have 7. Also we have 19 minus 12, like this. So 3 times 1277 would be 1, 3. This one should be 2, 6, 8, 3. 3,831. So, and this is the end of this video.